round at the very end. I would say in the middle of the problem, keep as many decimals as you can. So I have 0.15625 plus or minus 0.0472. Okay. So if I do 0.15625 plus that, I get 0.2035. And 0.15. I get 0.109. That is my 90% confidence interval. Okay. So if I'm taking a random sample of 160 students, and I find that 25 of them have smoked, then my 90% confidence interval is, I'm 90% confident that the proportion of students at this high school who have smoked is between 10.9% and 20.35%. So somewhere around 11 and 20% smoke. Are we running into issues here, or are we okay? Okay. How are we feeling? Good? Not good? Another example?
Yeah.
Yes? No?
Do we have another one?
What do you mean?
Are we learning a new one after this?
No, this is the last topic.
Okay, then yeah, another one.
Another example. Okay, we'll do one more example. Call it a night, sure.
Alright. Never mind, no
What?
No, go ahead.
Okay.
You get the final answer 0.027. You get the final answer and then you plus it 5, and then you minus it by 5. And we have those two numbers we get inside of those numbers. That's whatever you get from those numbers is correct.
No, it's not the same. Well, I don't know what I got this. I got this. So now I'm want to get in. And then ska komma med relativa
Okay, that's your problem. It says, what percentage of people own dogs? We take a random sample of 800 residents in LA and find that 29% of them own a dog. Make a 95% confidence interval for the proportion that own dogs. I think so. I hope so.
Or is it
Okay, what's 29%? What was that? So, what symbol was that? Okay, let's try this out. We have p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. This being my standard error. What is p hat? P hat is 0.29. P hat is our sample proportion. I sampled 800 people, 29% of them own a dog. So sometimes I give you the count of people who own dogs, and then you divide by 800 to get p hat. Sometimes I give you p hat directly. And you've got to be able to read a problem and recognize what information you have. Okay, what is the z that we're going to use?
1.95.
For 95%, we're going to use 1.96. My standard error ends up being 0.29 times 1 minus 0.29, 0.71 over 800. So this is equal to 0.016. Point 01604. Okay, but whatever. So when I combine all of this, I have 0.29 plus or minus 1.96 times 0.01604. I multiply that by 1.96, and I get 0.29 plus or minus 0.031. So I have 29% give or take, basically 3%. So I go from 0.259 to 0.321. Good? That's great. So then my interpretation is, I am how confident? 95% confident that what? That the proportion of what? People in LA who own dogs. Is between 0.259 and 0.321. Okay, that'll be it for today's lesson. We'll see you guys next week. Next week's quiz covers pretty much everything we've done in today's lesson, okay? So you've got to know how to check for conditions, how to use the normal model that I think in the note sheet it's called the central limit theorem, but it's using the normal model and then making confident numbers.